This is Precalculus, Chapter 9, Lesson 1. And it begins on page 571. So we're going to look at identities, trig identities, and how can we prove trig identities. And so I've sent you a handout, and I tell you what lesson they come from. So 9-1 are these and your negative angles. And I believe that there is a box on one of the pages that gives these, but all of these now are going to be on that one sheet. So the first part of the lesson deals with how to prove them by looking, by graphing them in your calculator. Okay, I'm not going to walk through those. But example 1, it tells you right here how to put it in your calculator. All right. Parentheses tells you order of operations. When you graph it, always, so you do the left-hand side in y sub 1, the right-hand side in y sub 2, making sure your calculator was in radians. And you would, the way that your calculator is going to graph it is, the very first graph that you see is going to be y sub 1. The second graph you're going to see is y sub 2. If they're obviously different, they're not identicals. They're not identity. They're not equivalent identities. If you see one, graph it, and then the second one looks like the line just gets a little darker, that's an identity. But we're going to work identities using algebra, all right? So I'm going to walk through the examples and give you a couple of key ways to help you work through these. All right, so there is a box on the top of page 574. You know the quotient identities. The tan is the sine over cosine, and cotan is just the inverse of that. You know the reciprocal identities. We've already looked at those. The periodicity ones are different, all right? And so are, well, not the Pythagoreans we've done. Negative angle identities are maybe new, except we really have worked with these. Because when we did the inverse, the sine and the tangents, so this is related to that. When we did the inverse, the sine and the tangent was in the first and the fourth quadrant. The cosine was in the first and the second. All right, so your negative angle identities are closely related to that, particularly for the sine and the tangent, because we were looking in the first and the fourth quadrant. All right, so you can read through that. And on the bottom of page 575, there's a box with some strategies. All right. So here are some strategies that I think are important. Well, and some rules that are going to be very important. We're not going to eliminate denominators. So that's key. When we're working trig proofs, we're not going to eliminate denominators by multiplying every term by something. We're not going to do that, okay? We're going to work independently on the left-hand side and or on the right-hand side, okay? We're going to work independently on them. We're not going to move between the equal sign like we do in algebra. All right, we're going to leave what's on the left-hand side on the left, what's on the right-hand side on the right. All right, if you can, I always try to write everything in terms of the sine or the cosine, if that's possible. The only time that I don't try to substitute in for like the cosecant, the secant, particularly the secant, is if on one side of the equal sign, I have the tan. So if I have the tan equals a blob, then I'm going to try to go to the tan, remembering that the tan is the sine cosine. I will use common denominators. So I am going to use and look for common denominators. I'm also going to look for conjugate terms. All right, so you'll see this as we walk through the proofs. And particularly, I'm going to look for conjugate terms when, and there's two examples just like this. So I'm looking at my extremes and my means. I'm so glad I taught you guys that, right? When like this is the cosine, so maybe my means is the exact same trig identity, and maybe this is 1 minus the sine, and this is 1 plus the sine. All right, so I'm always going to work these a particular way. All right, always. All right, so look for these things as we walk through the examples. All right, and I'm using my trig identity sheet. All right, so look at example 3. I'm also going to use association. So I'm going to associate things that I see that potentially go together and can be substituted for something else. So example 3 is 1 plus the sine of x minus the sine squared of x over the cosine of x equals the cosine of x plus the tangent of x. All right, I am only going to begin by working on the left-hand side. And as I write that, and you may not recognize this, but the Pythagorean identity is for sine. Sine squared plus cosine squared equals 1. So the sine squared plus the cosine squared equals 1. Well, I have a 1 and I have a sine squared. Well, cosine squared x is 1 minus the sine squared x. That's what I have. I have a negative sine squared x. I have a 1. I'm going to associate those and then substitute the cosine squared for that. All right? All right, so it's going to be 1 minus the sine squared x. That's what I'm going to substitute in just a minute. Plus the sine of x over the cosine x equals the cosine x plus the tan of x. All right, for that piece, I'm going to substitute in cosine squared x. So that I'm left with cosine squared x plus sine x over cosine x equals cosine x plus the tan of x. All right, these two terms are written over a common denominator. That's one other thing I'm going to look for. Can I split the numerators back apart and write two fractions? And you always can. You know, in algebra, we're always consolidating and simplifying. With trig and even towards calculus, maybe we're pulling things back apart. So I'm going to write the cosine squared over x plus the sine of x over the cosine. All right, so we have the cosine squared x. Why would I do that? Because I recognize that is just the cosine of x. And I then realize that that's the tangent. All right, so I didn't even touch this right-hand side. This one cancels out. We're just left with the cosine of x. The sine over the cosine is the tangent of x. Now, this is all going to be obviously new to you. So how did I know to do this? I followed the rules that I've learned, right? First I look and I see the tangent over here, and I'm not changing, well, the right-hand side is much more simplified, so I'm not going to try to simplify that. But when I saw a 1 and a negative sine squared x, I knew that that was a Pythagorean identity, or I knew it looked like one, so that I could simplify that a little bit. Then once I got to here, I realized, oh, well, that's just the cosine and that's just the tangent. Okay? So start somewheres. Start with substitution. Start with changing everything to sine cosine. It was already all in sine cosine. So I wanted to say, can I somehow simplify 2 of the terms into 1? Or maybe convert 1 term into 2, and maybe it be the tangent, okay? So you just have to start. But I always work on one side. All right, now look at example 4. All right, example 4 is the cosecant plus the cotangent. And already I'm thinking I want to go to sine cosine for both of those, all right? Times 1 minus the cosine x. And we're going to simplify that. We don't have an equality. We don't have to try to prove that it's something else. We're going to simplify it as much as we can. So that my first thought was go to sine cosine. This is already in sine cosine. The cosecant is 1 over the sine of x. The cotangent, all right, so the tan is sine over cosine. The cotan is cosine over sine. All right, I look, I have a common denominator. So this time I'm going to move the sign up and write it over its one common denominator. Because it's a conjugate to that. Did you see that? It's a conjugate. That's really over 1, right? I'm going to go ahead and multiply. Conjugates, you multiply the first and the last. Because when I multiply it, 1 times 1 is 1. Cosine times cosine is cosine squared x all over sine of x. That is a Pythagorean identity. That equals the sine squared of x. For the same reason that 1 minus the sine squared x equals the cosine squared x. 1 minus the cosine of x equals the sine squared of x. So now I'm going to use substitution, then simplification. All right, so this whole complicated expression, simplified, is just the sine of x. That's all it is. It's just the sine of x. All right, example 5. Oops, that was example 5, huh? 3. No, example 5 is on the bottom of the previous page. Okay, this is one that I want you to pay close, well, you need to pay close attention to all of them, but this is one where we have the means are the same, and actually the extremes are the same. The means are conjugates. There's always something I am going to do. All right, so we have the sine of x over 1 plus cosine of x equals 1 minus the cosine of x over the sine of x. All right. So see, my extremes are the same. My means, they are conjugate terms. I'm always going to take this term here. I'm going to multiply. I'm only dealing with one side. By that over itself. Never the single term, but always the binomial. Okay? Always. That's how I'm always going to handle these when they look this way. Am I going to distribute? I am not going to distribute. So in the numerator, we have the sine of x times 1 minus the cosine x. These are conjugates. I multiply the first one. I multiply the last ones. All right. Then, once I have done that, what is 1 minus the cosine squared x equal? It's the Pythagorean identity that we've looked at before, right? It's going to be the sine squared x. So I am not changing this right-hand side. I am only working on one side. That's what I typically do always, all right? So for this piece, I'm going to substitute in the sine squared. So that we end up with sine x times 1 minus the cosine x over the sine squared x. All right? I can simplify terms that are multiplied. I eliminate that. I eliminate that. Look what I'm left with. 1 minus the cosine x over the sine of x equals 1 minus the cosine x over the sine of x. All right, so it doesn't matter what side you work on. As long as you take this one, this term, if you're going to work on the left-hand side, you're taking this term, multiplying by what's effectively 1. If you're working on this side, I'm going to take that binomial, multiply it over itself. Because either way, you're going to end up with an equality. All right? That's example 6. No, that was example 5. Look at example 6. It is exactly, you're going to get to this same place. All right, so I'm going to work a little bit over here. And I'm only going to look at that left-hand side. Because the right-hand side is this. Okay? But I'm going to end up in this exact same place. All right, so in 6, we have the cosecant of x. The cosecant, Paula, cosecant of x minus the cotan of x, minus the cotan of x. So I'm going to go, because that's what's in the other side, I want to go to sine cosine. This is 1 over the sine of x minus the cotan is the cosine over sine of x. When I move that sine to the numerator, I end up with 1 minus the cosine x over the sine of x. See, I'm right here. And then I just work through. Multiplying. So it's just an added step, right? All right, that's example 6. It just takes practice. You have to practice and struggle with these, all right? All right, look at number 7. Example 7 on the top of page 578. is that? All right, look at A. Secant. It's not a very good one, huh? Secant of x times the secant of x minus the cosine of x equals tan squared x. I'm leaving the right-hand side alone. Okay, when I wrote this, I thought, well, the tan squared x has a Pythagorean identity with the tangent. So that 1 plus the tan squared equals the secant squared. So I'm going to go ahead and distribute that because then I can substitute in the tan. All right, so we have the secant squared x minus the secant of x times the cosine x is the tan squared x. All right. For this, I'm going to substitute in 1 plus the tan squared x. All right, so for secant, because it's multiplied by the cosine, I'm gonna convert it to sine cosine. The secant is 1 over the cosine, and that's multiplied by the cosine. This is just the cosine over the cosine. Or those cancel and it's -1. So it's 1 plus the tan squared x minus 1 is the tan squared x. My 1's eliminate because it's 1 minus 1. And we have the tan squared x equals the tan squared x. All right, let's look at B. So for B, as I write it, I then see my extremes and my means. One of them is the same value. The other ones are conjugates, all right? So, I see my means are the same. So it makes me think that I want to multiply that denominator by that first term, all right? And we're actually going to end up almost where we were in A. All right, so we have the secant of x over the tan of x equals the tan of x over, see, these two are a clue that I'm going to take a binomial and multiply it by one side. Secant x minus the cosine x. All right, so because these aren't conjugates, because those means, I'm going to take this exact same, which is what we did when they were conjugates. I took that side and multiplied it over itself. That's what I'm going to do. I'm going to multiply by the secant x minus cosine x over secant x minus cosine x. All right, so I'm going to leave this right-hand side alone. I am going to distribute this first one because I know that I end up with cosine squared. I know I'm going to end up with secant squared, which I'm then going to substitute in the tan. All right, so we have, a lot of times I don't distribute, but I see that I can get to the tan. I'm going to try to get to the tan. All right, secant squared x minus cosine x secant x. I don't think I'm going to distribute the denominator yet. For this term, I'm going to substitute in that 1 plus the tan. So I have 1 plus the tan squared x minus the cosine x. For secant, I'm going to go ahead and put in 1 over the cosine, because that's where I was in that very previous one. 1 over the cosine x. Not going to distribute this denominator quite yet. Right, this is 1, right? And my 1's cancel out. So I'm left with the tan squared x. So I'm left with the tan squared x over the tan of x times the secant x minus cosine x equals the tan of x over the secant x minus the cosine x. One of my tans eliminate, and I'm left with tan x over secant minus cosine. And that is, in fact, an identity. All right? So this really, when you have these, it doesn't matter if they're in the extreme position or the mean position. I'm typically taking the binomial and multiplying it over itself on the other side. And I'm not always distributing unless I see, like I saw in the numerator for the secant, I could get the tangent. So I wasn't going to distribute in the denominator until, I mean, at some point you might have to, or you might have to work with the denominator, but it's much easier if you can just try to work with just one side and either the numerator or the denominator, all right? All right, example 8. Now look at example 8. When I look at example 8, the cotans on the left, the tans on the right. So I'm always going to go to tan, sine, or cosine. So I'm thinking I'm going to work on the left-hand side. All right, so we have the cotan x minus the 1, cotan x minus 1 over cotan x plus 1 equals 1 minus the tan of x, and I bet it's 1 plus the tan of x. All right, so my first thought is I'm going to make the cotan 1 over the tan. All right, so it's 1 over the tan minus 1 over 1 over the tan plus 1. All right, now it's complex fraction on the left. I think I'm going to go to a common denominator. All right, so I'm going to multiply this term by tan x over tan x, and this term by tan x over tan x, and write both my, it's going to be 1 minus the tan x over the tan, 1 plus tan x over my common denominator tan. All right, so it's going to be 1 minus the tan of x over 1 plus the tan of x, over the tan of x. I was just skipping my common denominator, wasn't I? Over the tan of x, that's the numerator. And in the denominator, it's 1 plus the tan of x all over that common denominator, tan of x, equals 1 minus tan of x over 1 plus tan of x. Remember when we had complex fractions in Algebra 2? This was why. I take that denominator, I flip it, multiply it over itself. My denominator eliminates, the tan eliminates, so I'm left with 1 minus the tan x over 1 plus the tan of x, which is, in fact, the identity.